Okay guys, so we've been talking about standard form in quadratics, all right? And that tells you something about whether the parabola opens up or down. It also tells you where the y-intercept is, all right? Now, we're just gonna talk about another form of quadratics, all right? And this one's called vertex form. Okay, and this one will still tell you if it opens up or down. Still tells you if it opens up or down based off the a value that's in front of the x squared. Okay, but this one, even more than that, it's going to tell you where the vertex is. That's why it's called vertex form. All right, and so this is f of x equals x minus h squared plus k. All right, and the key thing on this is that your point, actually hk, okay, whatever those numbers are, hk is the vertex. Okay, so that is huge information for us. All right, all it's going to do is shift our graph around, all right, and it's going to shift that vertex over or up or down depending on what that is. So let's take a look at the most basic graph. So we call this the parent function. All right, so all the kids will come from this parent function. The parent function is f of x equals x squared. This is the most basic function that you have. It's really the same thing as saying 0x plus 0, all right, but we don't have to put that on there. So it's just f of x equals x squared. All right, we're going to look at what does that graph look like. And in order to do that, we're going to go old school here. We're going to make a table of values. All right, and we're going to see. So we're going to see what that graph tends to look like. All right, so we're going to plug the points in, -2, -1, 0, 1, and 2. Okay, and let's see what we notice about this. Let's say I start with 0, all right, the simplest one. 0 squared is just 0, all right, because if we think about 0 squared, that is 0. Okay, I'm going to start with the easy ones. 1 squared is 1. And obviously 2 squared is 2. Okay, so here's my graph, all right. I'm at 1, 1, and I'm at 2. 2 squared is not 2. It's early this morning. I'm running on no coffee. All right, 2 squared is 4. So 2 is all the way up at 4. And if you go back and you think about -1 squared is also 1, and -2 squared is also positive 4. Okay, and this has a pattern that we've noticed. Okay, you have an axis of symmetry there at 0, all right, which is -b over 2a. 0 over 2a is still 0, so the axis of symmetry is there. So every quadratic graph is going to go in this manner. All right, it's going to have this kind of shape to it. And do you notice our numbers repeat themselves? These numbers are the same as these numbers. All right, that's because these points are symmetrical to one another. Okay, so let's look at how does that help us out with something that's written in vertex form. Okay, so let's look at our first example. Let's say I have f of x or y equals, I've got x plus, let's say minus, let's go x minus 3 squared plus 2. All right, so right off the bat, this information tells me that -3 is my h value, positive 2 is my k value. So I know that my vertex is going to be at the point 3, 2. All right, and so let's look at our graph. Let's look at what happens. Okay, I know the vertex is at 3, 2. So 1, 2, 3, up 2. I know that that point is the vertex. Okay, and I also know from having a positive number out here in the front that my graph is going to open up. Okay, so what else can I find out? I know that it's got to go up in this direction. All right, so I really need to test the points on either side of 3. All right, and we notice that that is 2 and 1 and also 4 and 5. But I know I really only have to test the two to the left or the two to the right, and they're going to always match. They're always going to be equal because it's going to be the same on either side of this dotted line, which we call our axis of symmetry. That's my AOS. All right, and so let's just kind of check that. So here's my XY chart, and I'm just going to check. We know the point 3 is going to give us 2 when we plug it in. All right, and if I plug in, let's say the point 2. Okay, well, let's plug 2 into our basic function. I've got 2 minus 3 squared plus 2. Well, 2 minus 3 gives you -1. -1 squared gives you +1 plus 2. All right, so that's going to give me a +3. So at 2, we're going up to 3. And right off the bat, I know that 4 has to match because they're symmetrical points to each other. Okay, now let's check 1. If I plug 1 into my function, I got 1 minus 3 squared plus 2. Well, that's -2 squared plus 2. Well, that's 4 plus 2, which is going to give me 6. So 1, 2, 3, 4, 5. All right, all the way up here at 6, I would have a point. Almost running out of room here on my graph. Okay, but the biggest thing is the way this function was written. All right, we had f of x equals x minus 3 squared plus 2. That told me where this vertex was right off the bat, right out the gate. Okay, now let's look at another example. All right, example 2. So here I'm going to say y equals, I'm going to have x, I'm going to say plus 2 squared plus 4. Okay. Well, I noticed that this sign changed. All right, it changed from a minus to a positive, and my formula calls for a minus. So the only thing that would make a minus sign change to a positive is if this was like x minus -2. Okay, so I know that my vertex point is actually going to be at -2 and 4. So here on this particular one, the vertex is at -2, 4. So that's going to help me out. All right, I know some things about this. So at -2, here's -2. All right, there's +4. There is my vertex. Okay, we also know that this graph is going to open up because it's a positive graph here. Okay, so let's try points on either side. All right, I think maybe -1 and 0, because I know those are going to be the same as -3 and -4. Okay, we know that this is the axis of symmetry, all right, or the AOS in shorthand. Okay, so moving forward, let's look at these. Let's see what happens when we plug something into our function x plus 2 squared plus 4. All right, so let's plug in -1. So when I plug -1 in, -1 plus 2 squared plus 4. Well, -1 plus 2 gives me a +1 squared plus 4. All right, and that would give you 5. So at -1, so if we're doing our XY chart here, -2 is 4, -1 is at 5. So -1 is just one above that at 5. Okay, which tells me that on the other side at -3, we're also going to have 5. Okay, and then finally, let's plug in 0. So 0 plus 2 squared plus 4. And what do we notice? That's 2 squared plus 4, so 4 plus 4, and that gives me 8. So at 0, we're at 8. So 6 and 8. So at the point 0, 8, that is my y-intercept. All right, and I am good to go. So here I have a very specific, it's not just a sketch anymore. This is an exact representation of the function f of x equals x plus 2 squared plus 4. All right, and vertex form is very helpful when I'm going through and graphing these things.